recording.
Okay, hello everyone. Thank you for joining us for this meetup called Big Data and AI Developers and Chicago ML Meetup. Data and AI Tech Buffet, Part 2. And thank you very much for my co-organizers, Garrett, Mary, and Ron, and I'm Svetlana Levitan. And today we are having this meeting online, so hopefully there won't be any problems. Well, even if we work together, I hope we wouldn't have any problems, but just as a rule, we are dedicated to providing harassment-free community, so please do not upset other people and be nice to each other, and let us know if there are any problems. And if you want to sign up for a free IBM Cloud account, you can use this link here on the screen. It's ibm.biz/capital B, lowercase d, q, n, and then capital S and capital G. And that would give you free access to a number of interesting services. And today we have a very packed agenda. So we'll have those lightning talks. I promised Franco that he can have up to 15 minutes because he didn't have enough time last time to present his talk about Spark 3.0, and that must be very interesting for most people, I think. And then we have 4 people who have spent many years working for IBM and now are looking for new opportunities. And then at the end, Luke will also tell us about something very interesting in SageMaker. Okay, any questions about this? Any concerns?
Looks good.
Okay, okay, then I guess Franco, you can take it from here. So yeah, so other talks other than Franco, I plan to try to limit to about 10 minutes, okay?
Okay.
Hope it's not a problem. Okay, Franco, you can take it from there. Thank you.
Thank you for that. Thank you, everyone. I'm going to start sharing my screen. Can everybody see my screen?
Yes.
So, hello, my name is Franco Patano. I am an Enterprise Solutions Architect with Databricks. I work out of the Chicagoland area. I live in Bolingbrook, and I've been attending these meetups for a little while now. I apologize for the children in the background. I'm giving my wife a break from managing the kids all day. So they're here with me on this meetup. But anyway, I work with enterprises in the area to help them figure out how to use Apache Spark and other products on Databricks and help them with their workloads. So I'm here to talk to you about Apache Spark 3.0, but I also want to let you know that the Spark and AI Summit is coming next week, and it is completely free. So you can sign up, and all of our content, because everything is virtual now due to the pandemic, Spark Summit is completely virtual and it's completely free. There is going to be free training the first 2 days, so you can sign up for that. There's also paid advanced training, and there's also going to be great content over the following 3 days of next week. So if you want to sign up, please feel free. So just a little bit about who's Databricks in case you didn't know. The original creators of Apache Spark incorporated and found their own startup called the Databricks. You've heard of that, but if you haven't heard of what we've been working on lately, the other open source projects is Delta Lake and MLflow. Okay, so what's going on in Spark 3.0? There are a lot of updates. There are a lot of core functionality that has been added to Spark that makes interactive queries more performant, as well as other functionalities that make it more convenient to code and to get scalability for these large-scale data pipelines. I unfortunately do not have enough time to cover all of them, so I'm going to be picking a few to go over to discuss them. One of the most important, what I view as one of the most important updates is the adaptive query execution. So what does this mean? Well, there were in Apache Spark 1.0, they introduced some querying capabilities. In Spark 2.0, it brought some additional options to be able to analyze statistics of the cost-based optimizer was introduced in 2.0, and essentially it took into account how long the query would take given statistics. Unfortunately, if you ever use the cost-based optimizer, it's not perfect. It doesn't really understand the complexity of it, and especially if you decide to skip the statistics stage, if you want to increase performance, it's really not going to help very much at all. So what we have, hold on one second. All right, sorry, there's Minecraft going on in the background. It's very important. What happens is that there's a better, we enhance the way that the adaptive query execution works in Spark 3. So now it not only accounts for rules and costs from Apache Spark 2, but now it accounts for the runtime, so that if it identifies a better plan that can execute quicker, that it will change mid-run to that adapted plan. And this is sort of what that looks like, adaptive query execution while the job is actually executing. What happens is the parser analyzes what's coming in, and it has an unresolved logical plan, and then it develops a logical plan. And then the optimizer optimizes that plan, and then it will go to the physical model, to the cost-based model, and then it will go into the physical plan to query execution. But if for some odd reason the query execution is not being executed the way that the statistics thought that it should have been done, so based on the original execution, it will actually go back and adapt the plan to the logical plan and adjust optimize how it's running, so that if it can finish faster by optimizing one of the join types, or one of the most common things that we see in the field is converting. Sort merge join is great. It's what really kind of brought Spark its capabilities. If you remember the sorting competition that Spark won, it was sort merge join that kind of was the thing that kind of made it work. So unfortunately, not everything is sort merge join. With data warehousing type queries, you have dim and fact tables that are smaller, and that's not always the best thing to do. So there's also broadcast hash join, which in some plans actually executes faster. So what's happening here is that Spark is getting smarter at understanding what is going on with the data, and it will actually adjust the plan. In Spark 3, it will now adjust the plan and re-execute based upon new statistics or adjusting the join types. So what happens here, what is the magic? Like, what's going on behind the scenes? So essentially what we need to do is shrink the number of reducers, convert that join type from sort merge join to broadcast hash join, and then also handle any skew join. So another of the very common Spark tuning problems is how the skews are managed in execution plans. And those are the types of things that have been adjusted. So again, these are some points that the kind of how it decides, or how does this actually lead to better performance. And essentially, so when you want to join a table, and because memory is now becoming more prevalent in these virtual machines in the cloud, you can actually okay, I'm sorry, I just thought I heard somebody. So if you can broadcast the table, so if your memory inside the cluster can actually handle the ability to broadcast those smaller tables, maybe we need to increase the broadcast join threshold, so we can do that. The stats aren't necessarily always accurate. File sizes can be compressed, and then you have out-of-memory errors. There are sometimes when we engage with clients or people that are using Spark in the field, we find that they could issue the broadcast type hint. And it's something that would need to be tuned use case by use case. And that's not something that's scalable. It should be something that's built into Spark. And so that's what's happening here. So what happens to actually make, what actually happens to make this work is that if you think about how you'd be joining records together, you could have two tables that need to be sourced. And essentially in a sort merge join, you would have the children that could be brought up into the join, and there would be these various processes. And essentially both objects are sorted, and then they are merged to join together. With the broadcast hash join, if we can actually take one of the smaller tables and broadcast it to the cluster, so every node on the cluster has a copy of the table, that join becomes much more efficient because we don't have to do the sorting and the merging afterwards. We can just broadcast one side of the join, and all of the nodes in the cluster have that table in memory, and the joins become significantly faster. So, shuffle partitions. I know this is a major issue with a lot of performance tuning in Spark. The default is 200, but unfortunately no one can tell you why the default is the way that it is. And oftentimes what we find in practice, partitions can be too big. You can have spill during different types of actions and aggregations and sorting, but then sometimes if it's set too big, your partitions are too small, it's not optimized, and then the scheduler has more pressure on it. So what does adaptive query execution do? So what it can do is actually manage the shuffle strategy so that it benefits the join. And what that looks like, even in a short merge join, if there are, depending on the number of partitions that those tables have allocated to them, if we can reduce the amount of partitions that is in scope, then it will make the shuffle operation more performant. So this is visually how that adjusts the plan in real time. Skew joins. So skew joins is another very common issue that happens in the field, where you have a partition skew where some partitions can be smaller than others, and then you're basically waiting for the last node to complete the calculations in order for the job to be done, which does not lead to great performance. So what happens here is that it will split the shuffle read between the sort operations to optimize the total reads that are getting ingested into the sort merge join. Dynamic partition pruning. This one's interesting. So if anyone's tried to use data warehousing like queries on Spark, SQL, you'll understand that the performance is not as great as something that you would get out of like a traditional data warehouse. And that's because a traditional data warehouse can tune for star schema, snowflake schema type of schemas with their various tuning techniques. So one of those techniques is based on a similar predicate pushdown. If we don't need the data that's in the file, don't bring it in, right? So now this works with joins, where if in the second table that you're joining to, the filter, the join criteria you're applying on the key will filter out some of those records, it will then push that down to that source object. So we will know, this Spark will no longer bring in the data that is not even included in the join criteria. This makes performance on queries that are highly selective or have predicates which highly select out like files or whole files or partitions in the query, and it makes performance significantly faster. And to kind of visualize what that means, I know TPCDS is not an indicator of reality, but unfortunately it's what a lot of people use to benchmark their queries. You can see that the speed up is significant with dynamic partition pruning across the board. So it's not just one query on particular, it's actually across the board. There's significant speed ups in those queries, and significantly you can see the speed up in query 25. So what does this mean? This means that you actually get decent performance for your warehouse type queries in Spark now. So what we've seen in the field is that with these enhancements in Spark 3 on TPCDS, we see significant performance improvements. And it actually is a contender now with common, closed source proprietary data warehousing software. All right. So Project Hydrogen. So some of you might be aware of the work that's been done with GPU scheduling in Spark. So this is one of those, it kind of feeds into that project overall. But essentially, it is gang scheduling to Apache Spark, and it includes distributed deep learning job as a part of the Spark stage. What does this mean? It means that the scheduler is now aware of GPU acceleration, which if you have deep learning workloads that leverage deep learning framework, you know that right now there are ways to get this to work. In Databricks, for example, we have GPU clusters, but we kind of built a custom built solution for it. Now there's a solution in open source Apache Spark that supports Yarn and Kubernetes, and now it actually supports GPUs and actually FPGAs and TPUs in the future. So with this, if you do attend Spark Summit, there are talks from NVIDIA that actually accentuate this even further. And NVIDIA actually has this interesting talk around doing ETL on GPUs, which I find interesting because a few years ago we were analyzing GPU databases on SQL. I think I'm almost done on time. Do we still have time?
Yes, you have some time.
Okay. So GPU discovery in standalone mode. Here's kind of the get started script on how this works. And essentially, you'd have to replicate the worker configs in order to get discovery set up. And then you add some application configs with your GPU settings. And then you can write code to leverage the GPU. And the scheduler is now aware of the GPU. If I need to wrap it up, please feel free to let me know. The other thing I want to cover is join hints. So one of the, as we kind of articulated earlier with the adaptive query execution, you also have now a more variety of joins that can be applied to your different join strategies. We've talked about sort merge join. It's pretty much the most robust and most commonly used join in Spark. Now we also have broadcast hash join. It requires one side to be small, very common in data warehouse queries. Shuffle hash join. This is when you need to shuffle the data with no sort and you have really large tables. But if you have skew, it can cause an out of memory on the workers. And then you also have shuffle nested loop join, which I think I need to research this a little bit more. I'm pretty sure this has to do with something with like Cartesian products in some situations. You can apply these join hints inside your Spark SQL queries by following the syntax. There were a lot of new built-in functions that have been added, too many to count. There's one last thing I want to cover, and if I'm out of time, I can wrap it up. But another pretty important update that was made, especially for this group, since most commonly data science and ML is done with Python and or R, a lot of updates have been made to Pandas UDFs in Spark 3. And what I feel that they are significantly easier to program now, and they make more sense as someone who's learned Python programming. And now there's a new interface with type hints, and there's a way to encode your Pandas UDFs that seems more logical when you're developing functions. And for those who don't know, Pandas UDFs are a way to scale up arbitrary Python code on Spark without having to write Spark code. So you can create a function, and then you can distribute or parallelize that function on the cluster, depending on the type of iterator that you're using. We also have new iterator types for map pandas UDF, where the iterator of the data frame goes to the iterator of the data frame, and then co-grouped mapped pandas UDFs, which you have a pair of data frames and you want to go to a data frame. I guess I still have time. The last thing I'll mention is the new explain formatted, only because I know how painful it is to sometimes work through the explain plan when you're trying to understand your queries. But now there's a new function called explain formatted that kind of formats the explain command in a little more legible manner If I still think it needs some work, but essentially it leads to much more readability when you're trying to understand the explain plan. With that, I'll kind of pause there. Any questions, or is that the end of the talk?
Okay, sounds good. Thank you. Is there any like call to action or something, or where can we find more information on this?
So if you want to learn more about what's going on in Spark 3 and maybe dive a little deeper, definitely attend Spark Summit next week. We also have a recording of a deep dive where I think Xiao or Zhengming posted on our YouTube channel for Databricks, where he went into a deep dive into all of these a lot more features and functionality of the code, but more will be coming out soon. You can use Spark 3 pre-release right now. The source is available. You can also use Databricks. We have it pre-packaged in Databricks Runtime 7.0 beta right now.
Great, thank you so much. Any questions to Franco? Anybody have questions? No? Okay, thank you, Franco.
Thank you.
Let's see who is the next in my plan. Where is my plan? Oh, yes, Shatabdi, please.
Okay.
And then next will be Damir.
Okay, I'm going to start my screen.
Yes.
Okay. You see my screen?
Yes, very well.
Okay, hi. My name is Shatabdi. I am software engineer at IBM. Currently working in Cognos Analytics. I'm a student at DePaul University as well, and I used to be a student in Northwestern. So today I'm going to talk about evolution of ensemble models. Okay. So first we're going to discuss collective intelligence. So what is collective intelligence? Collective intelligence occurs when a group of people act collectively in ways that seem intelligent. The nature is filled with examples of collective intelligence. Something like bees building beehives, birds flying together. An individual ant is not very bright, but ant colonies turn out to be surprisingly efficient. Wisdom of crowds and ensemble learning are similar in principle, like teamwork. Everyone has their opinion, their specialized knowledge, and then aggregation of a collective decision. Ensemble learning or model averaging is used in machine learning to improve performance by grouping individual models. This is like a timeline of the ensemble models. So it started at 1979. That's pretty early, right? So it was initially suggested by Dasarathi and Sheila in 1979. And it was called as a composite classifier system. That's like a that's an ensemble system in a divide and conquer fashion, partitioning the feature space with 2 or more classifiers. Then came bagging, which is bootstrap aggregating. Leo Breman, he is the one who brought up this idea. And then boosting. Boosting has different types. We will see that in following slides. There is gradient boosting, which was developed by Friedman. And then there is ADA boosting, and there is light GBM, cat boost. So the idea of gradient boosting was originally from Leo Breman, who's the founder of bagging. And boosting is kind of interpreted as an optimization technique with a suitable cost function. The gradient boosting algorithm is developed by Friedman. And then finally in our list is XGBoost. It's started as a research project by Tianyi Chen in 2014, and it's very popular in the Kaggle community. because it produces very accurate model with very high accuracy. Now we're going to see random forest. So random forest is one of the bagging model which we saw in the previous slide. The decision tree algorithm is, quite easy to understand and interpret. That's why it's very, very popular. But often, a single tree is not sufficient for producing effective results. And that's where the random forest algorithm comes into picture. Random forest is a tree-based technique that leverages the power of multiple trees for making decisions. It's the name suggests, the forest of trees. But why are we calling it random? It's because it is a forest of randomly created decision tree. So each node in the decision tree works on a random subset of features to calculate the target or the output. The random forest then combines those output of individual trees and generate the final output. So the next one is I have the pseudocode. So if any of you are interested, you let me know after the meetup. I'm not going to explain this. It's going to take time. Next big ensemble model is gradient boosting. Gradient boosting is a technique for both regression and classification, which produces prediction model in the form of weak prediction model. And typically they are decision trees. And this is the pseudocode for gradient boosting. Now there are four popular boosting technique used nowadays, which one of them we saw gradient boosting, and then extreme gradient boosting, and light GBM and cat boost. We're going to look into it a little bit. So gradient boosting is the one we saw that that learns from weak learner, weak trees. So they are quite useful, and they make produce good accuracy. The next one is extreme gradient boosting. So that is like kind of like improvised version of gradient boosting. So the special of extreme gradient boosting is that it uses the parallel processing, which makes it faster. And it also uses different kind of regularization techniques, which reduces the overfitting. Because these models are actually, a lot of time they do overfit. And the next one in our list, we have light GBM. So light GBM is becoming really popular. This time, Svetlana and myself, we did the Kaggle, we were trying to use light GBM. So light GBM is very popular because of its speed and efficiency. It is able to handle huge amount of data with just very easily. But it does not work well with when the data is small. And the final one we're going to see is cat boost. So now, as the name suggests, it is actually the boosting algorithm that can handle categorical variable in the data. So a lot of the machine learning algorithms cannot work with categories, but this cat boost is quite famous for that. The next one we're going to see what is the difference between bagging and boosting. So the first one in the left you see the single classifier, and then bagging, and then the boosting we have. And I have here the points where we can see these two are different. So bagging is actually where it is each of the trees are independent. So it does not depend. So one tree does not impact the next one. But boosting is that. Boosting is actually influenced by the performance of the previously built tree. And the bagging, the best thing is that it is supposed to decrease variance, not bias. But boosting is the other, just the opposite. And bagging, every model has equal set. But boosting is not that. So models are weighted. When the final, you see the final accuracy, then they are using the weighted model. And where will you use bagging? If you see your classifier is unstable, then you can apply bagging. And if you see your classifier is stable but it has high bias, then you can use boosting. Okay. So how the output is combined? So usually they are combined by these two types, algebraic or voting based. So the algebraic combiner are used for continuous kind of target output. There can be like minimum, maximum, sum, or mean, or weighted mean, or product, or median, this kind of combiner. And for the categorical output, usually voting based methods are used, majority voting or weighted voting for boosting techniques. And this slide kind of shows like how you can use those ensemble models. In Python, you can use sklearn, scikit-learn, and you have AdaBoost, gradient boost, all random forest. There is also separate libraries for XGBoost, CatBoost, LightGBM, and similar libraries are there in R. And also, I also want to mention the PSM algorithm, pass string merge algorithm. This is an optimized approach to build ensemble models for very large data sets in a distributed map reduce environment. And this was by our IBMers, Ates, Niall, and Dimitri. And that's all I have. Thank you so much for listening. Any question?
Thank you, Shatabdi. Somebody wanted to ask question?
Let me see the chat.
Make sure you're unmuted if you want to ask question. Well, I don't see questions so far.
Okay, I'm going to stop sharing then.
Thank you, Shatabdi. Very good.
Thank you.
Damir, please.
Okay. Okay.
You want to start? Yeah.
Can you see my slide?
Yes.
Yes.
Yeah. Very
Okay,
good.
thank you. Okay, I'll talk today about feature selection for clustering. My name is Damir Spacek. I'm working in IBM and worked in SPSS for quite some time as a statistician and data scientist. I just want to bring up this capability that's tied to clustering. It might be well known, familiar, even people who use clustering in machine learning. But I think it can be useful in a number of situations. This has to do with particular clustering algorithm here, which is two-step clustering, available in IBM SPSS modeler. Tying to that previous talk, especially the first one, also Spark, there is a MapReduce algorithm analytics server running modeler. So depending on your version of modeler, or if you're working in ML Studio, you can also be able to tap into this algorithm. It does work for large data, but I'll focus more on the kind of statistical or machine learning type of feature here and benefits of it. So I'll talk a little bit about what is two-step clustering, how it works on a high level, and then look at feature selection approach and how it is applied to a couple of examples. So clustering features are kind of important really depending on what your analysis of the goal is for the clustering. Sometimes people can just put all the features in the data, but usually it may not be a good idea depending. You may cluster, for example, a behavior, and then try to find out what are the groups that are similar according to behavior. So you would look at certain fields in the data to cluster by. So it has some art in the application. And so features are all important because in unsupervised learning, there's no target, but basically all the features are treated as both input and target. There is usually not no sort of specific a metric you want to evaluate, so you can't just toss out other features that are related that easily. But here we're looking at features that are redundant and informative. And sometimes features can be detrimental to clustering, because if you have a large number of features, it leads to dimension explosion, and then your clusters can be pretty poor, not really well defined. So it makes sense to limit the number of features from multiple views. Not the least, of course, the applied view, because you want to gain sort of insights into, in the end, what drives the clusters. And for clustering, most of the algorithms work for continuous features, but two-step supports both continuous and categorical. And it does provide this feature selection capability as outlier detection capability, which can be also very useful working together with this, because sometimes you get some outliers that are really blurring your clusters a lot. You're not able to get a good solution because outliers are pulling clusters away from where they should be. So I'll go quickly about over this part, which is about really how two-step clustering works. It has a sort of, it's designed to be fast for large data. So you have pre-clustering step, which puts the data, sort of aggregates data in a lot of small nodes, and they are called clustering feature nodes. And so for each feature, there is a summary information in terms of means, variance, counts, and such. And then once you get a reasonable number of nodes, 500 or in that order, you can do hierarchical clustering, which can be pretty accurate. And that has some benefits in terms of trying different number of clusters and other features. So for distance function, that helps with feature selection is log likelihood. There are some other techniques also for continuous data, but I'm not aware that some provide for both continuous and categorical. So Gaussian distribution for continuous, multinomial for categorical, and then combining the two for the mixed type of data with both features. And then the distance functions are based on the log likelihood, and basically you merge the clusters, the ones that cause the minimal decrease in log likelihood. So coming to the feature importance, then once you have the solution, you can look at information criteria, because you work with likelihood. And essentially the idea is to compare to a null model per feature. And so each feature is compared to the null model. It's normalized by the max difference. So this gives you feature importance and ranks the features. And then if some feature has negative importance, can be readily excluded. So for example, textbook iris data, small data, 50 record per species. There are 4 measurements, and here we have feature importance, how it changes between among the 4 things. But we are looking to exclude, of course, the ones that have the least feature importance, possibly from the solution. So the feature selection is now based on the approach that we exclude any sort of negative importance and find a solution. And then for the rest of the features, we tried, starting with the least importance, we tried by removing that feature from the solution and then comparing the leftover information criterion value and combined with that excluded feature to gain comparable number. And if that number improves on the original solution, then the feature can be excluded. So for example, here, sepal width for iris data is excluded. And here you can see at the bottom is categorization of the clusters, how the species distribute across clusters using all the features or all the 4 features. On the right, just the 3 features with sepal width excluded. You can see they are pretty similar. And one way to summarize is using adjusted rand index. So with all features, it's 745, 758 for adaptive features. So it's even better without that last feature. Silhouette coefficient also gets better. Another interesting example is waveform data. The characteristic is also has 3 clusters, and then here 1 features that are relevant and 90 features are tossed as noise. So we have a deliberate noising of the data here, and the question is how well the algorithm does. What we get is if you use so there are slight differences in AIC and BIC criteria. So AIC retains 22 features, mostly those that are the true features. It includes most of the noise features labeled from 22 to 40. BIC is slightly more aggressive and includes all the noisy features, but also a couple of the relevant features. And as you can see in the table, the adjusted rand index is not, again, based on that classification, is slightly better for all features, but remains pretty stable. So in other words, you end up with the features that are really relevant for the clustering solution. So this would be pretty much. You can shoot me an email if you have questions, and you can, of course, ask questions right away.
Thank you, Damir. Any questions? No? Well, if you signed up for that IBM Cloud account, you can get access to this algorithm, I believe, right? In Watson Studio.
Yes, I haven't, sorry, I haven't brought any information like that, action information. I'm sure you can use it through, at least through a trial account on the ML Studio for IBM.
Right. Okay, thank you so much, Damir.
Thank you.
So no more questions? Okay, and the next one is who? David, right? David, you're on mute.
There we go. Can you hear me
Yes.
okay?
Yes.
Okay, beautiful. So I'll go ahead and share the screen. And can everybody see this okay?
Yes. Wonderful.
Okay. Okay, do you see just one screen or multiple screens?
One screen that says what is natural language processing.
Okay, beautiful. Okay. You have a pretty light presentation today. And we'll go over natural language processing, some of the issues with it, and some advanced or the latest advanced technology that looks very promising for improving results of natural language processing. Okay, it is a branch of artificial intelligence that deals with the interaction between computers and humans using natural language. And its ultimate objective is to basically make sense of human language in a manner that's valuable. Okay, NLP is used for language translation, word processors such as grammar checks, interactive voice response systems, and personal assistants such as Alexa and Google and many others. Okay, now the human language is a very complex thing, and here there are some reasons why it's very difficult to actually implement an NLP system with a computer. One of which is lexical ambiguity. You know, when you see a word in a sentence, we have a certain ability to discern, like say the word bored, if it's being used in the context of a noun or a verb. Computers have a little bit of a hard time with that. Syntax level ambiguities, such as he lifted the toy car with red cap. Did he use the cap to lift the toy car, or did he lift the toy car that had a red cap? So those type of ambiguities very tricky for a computer. And referential ambiguities are when we start using pronouns like the word it, he, she, always knowing what that refers to creates some issues. And one other very interesting thing that you guys might want to check out is this Ludwig Wittgenstein, and forgive me if I'm mispronouncing that, but he's a philosopher from about the time period of last World War, and he came out with a seminal work, which I believe was in the top 20 of the things that have been written in the 20th century. And he came up with this concept of language games. And essentially what it says is that language is truly, it's really hard to code language because of how we communicate with each other. We could have our own special meaning for words when we're talking, which makes resolution of what's being said nearly impossible. And it's just a great work. I highly recommend that. Okay, so we use these different techniques to make sense of what's written or what's spoken and converted to text. And one of the biggest ones is syntax. And one technique we use is lemmatization. And when we're actually developing a language model, we account for this lemmatization, such as equating the word president to equal chief, or which would equal top dog. And so we give the language model a leg up on how to interpret words that really mean the same thing in the context of how a particular article was constructed. Morphological segmentation is another technique where they take words and break them apart. And the example here would be guitarist. So guitar implies an instrument and the ist implies a person. So the meaning of that would be a person who plays guitar. Word segmentation is another technique. And this is really useful for when you have large bodies of text, and sometimes people run words together, such as you are. Through the segmentation process, we're able to tell the computer, that those two words are actually two separate words, like you are, as opposed to being run together. And many other algorithms or word segmentation is also used in a number of other algorithms. Parts of speech tagging, this involves identifying parts of speech, nouns, pronouns, verbs, adjectives, etc. Okay, then there are other techniques in there with syntax. Those are the main ones. Then we get to this concept of semantics. Semantics analysis is one of the most difficult aspects of natural language processing, and people are still struggling with this. And semantics really refers to what is being meant or being said in text, particularly sentences and perhaps even paragraphs or stories. Then we get one of the latest technologies that have come out is BERT from Google, which has accuracy rates around. And in a nutshell, unsupervised tasks that what they call fill in the blank. And also it does sentence sequencing. Does sentence B come before or after sentence A? And the model that is currently being used is 3.3. It's a 3.3 billion word corpus, which is phenomenal in size. And instead of processing words like in a sentence from left to right, essentially what they do is they go from left to right and right to left. And this will become important momentarily. And this diagram here shows how BERT architecturally works a little bit differently than OpenAI, GDP, and Elmo. And here is a perfect example problem that BERT handles well. Sentence is the animal didn't cross the street because it was too wide. So when we look at the word it, after the segmentation, when we ask the computer, okay, well, what does it refer to? It's most likely like a left to right type of algorithm or technique. It's going to believe that it belongs to animal, and this is not exactly correct in this context. Here, it is referring to the street, which is the second object in the sentence, and we have this what they refer to as self-attention, and this allows the model to look at other words in the input sequence to get a better understanding of what that word means. So going forward and back creates that uncertainty for it to resolve what that meaning is. And yeah, it's just absolutely brilliant. In terms of their achievements, they are achieving a glue score of 80.4, which is actually an increase of 7.6 over the next best, and 93.2 accuracy on being able to do question answers. That's what Squad is actually referring to. And one of the nice advantages of this is that by using these pre-trained models means that there are only very few tweaks you would have to make to the BERT system to be able to leverage. So the amount of retraining that's required is actually minimal. Okay, and here I have credits for some of the articles that this information came from, some terms, and thank you very much.
Thank you, David. Very interesting. Any questions? People are so quiet today. No questions to anyone. Oh, well. Okay, thank you, David.
Okay, thank you.
Now, who is next? Is it me? Oh, yeah, I'm next. Okay, question. So I can present this talk that I presented last week at CJAG, which is deploying JVM-based machine learning pipelines with open standards. Or I can present another talk about open standards for machine learning model deployment. Which one do people prefer?
Yeah, I would like the second one, Svetlana.
Open standards for machine learning model deployment? Okay,
Okay,
somebody says JVM. Well, both of them are about deploying, and One of them just talks about those open standards more, and the other talks about machine learning with JVM a little more. Well, I guess I did present about open standards several times before, so maybe let's do the JVM one, and I can just show a little bit more about open standards anyway, because they are part of it. Okay, thank you. Let me share. Yeah, so I have to share the whole screen. Share. Okay, so we're not sharing this one. Come on now. Sorry, let me. I need to open the right one before I share. Sorry. Okay, so this one. Okay. Yes. Okay. Okay. I hope you see it, right?
Yes. Yes.
Okay, thank you. So today I'm going to talk about deploying JVM-based machine learning pipelines with open standards. And so we'll talk about a little bit about machine learning lifecycle, and then we'll talk about how to build machine learning pipelines with JVM-based languages and packages. And then we'll talk about open standards for machine learning deployment, but very briefly. And then we'll apply those standards to, we'll talk about applying those standards to those pipelines from number 2. So first of all, about machine learning lifecycle. Well, as you know, machine learning is not just, okay, you take your data, you build your model, and you're done, right? Well, it's more complicated, of course. So first you need to find the data that you need to use, maybe pull together data from different sources, join it, etc. Then you have to clean the data, to analyze it, transform, apply some feature engineering, etc. And then you build models, and you probably build a bunch of models and try to see which one works best. And then suppose finally you have a great model. Is it the end of the story? Well, usually it's not the end of the story, it's just the beginning. Now you have something that you can put into production, so you could get predictions for new cases based on this model. And that way you get your return on investment. And again, once you put it into production, which is called deployment, it's not exactly the end of the story either, because you have to monitor how the model behaves. And with time, the trends in the data may change, and then you need some new model. So you have to update, and to update, you collect more data, and the whole cycle repeats. And well, actually, you don't deploy just a model. You need the whole pipeline. And what does it mean to have a machine learning pipeline? It's a set of series of operations where the data flows from some data source through various transformations. Well, in this picture, this is a what is called the SPSS modeler flow from Watson Studio, just to illustrate how it may look, this pipeline. So this is an example of pipeline. So on the left, in the purple circles, you have some data sources, and then you do some aggregation on this top one, some filtering, and then you merge those together by some kind of join, right? And then you fill in missing values and apply some partition, and probably into training, testing, whatever. And then you build some models, and after you build the models, then basically you have the pipelines that you can deploy into your production. So why do I want to talk about JVM-based machine learning pipelines? Well, the main reason was because I needed to present this talk last week at CJAG meetup, so I needed something JVM-based. But in general, it's actually an interesting question because, of course, if you look at most courses on machine learning, they all talk about Python, Python, Python. But we all know that, or maybe R, but both, we know that Python and R, they usually require all the data to be in memory. And of course, in real life data situations, it's not always possible. And on the other hand, Java is pretty widely used. You know, it's been around for a while, like 25 years, I think. So it's well established at enterprises. And Scala, of course, is newer, but it combines this object-oriented programming paradigm with functional programming. And of course, Scala is used in Spark, which we all know is great. Yeah, and so those JVM-based languages provide portability, scalability. They are strongly typed and pretty fast. And there are many open source libraries that we can take advantage of. So for big data, of course, you need either Hadoop or Spark, and then there are also Apache Flink, and Kafka helps in many situations, and Hive, etc. So there is definitely a strong case for JVM-based machine learning pipelines. And in fact, there are so many different libraries that you can use to build machine learning pipelines in Java. Here you can see a good set of examples of such libraries. This file actually I stole from a guy from IBM who is in India, I think. And I think it has pretty good representation for those libraries. At first I started creating my own slide, but then I found this. And I thought, oh, that's good. So this has Apache Spark because Spark, well, Spark itself is not machine learning mostly, but Spark ML, of course, is machine learning. And then RapidMiner is an open source Java library that has pretty good capabilities for machine learning. And there are some other libraries well known as well. Okay, now, how do we deploy those models? So suppose we used one of those packages and we built this pipeline. Now, how do we deploy them? There are several ways to deploy models, of course. But today I want to talk about open standards for machine learning model deployment, because open standards provide a way to easily exchange models between different frameworks. Very often in big organizations, people who are building models and those who deploy them into production are in different teams, perhaps even in different continents, and they may be using different programming languages and different environments, whatever. So you need a way to easily exchange models between different frameworks, and that's where open standards come in very handy. And the first such standard was PMML, predictive modeling markup language, which is XML-based standard that started back in the 1990s. And it is pretty widely used, widely known. And I'm a release manager for PML for the last several years. And I've been working with PML since about 2001. So if you ever have any questions about PML, let me know. And you can find information about PML at dmg.org/PMML. Sometime around 2013 or so, we had, in 2013, there was this conference, KDD conference in Chicago. And I remember there was a person who was one of those working on PMML who said, you know, we want something JSON-based. We don't want XML anymore. Now everything is JSON-based. Why don't we have PML in JSON or something like that? And so at that time, Bob Grossman, who was the founder of the Data Mining Group, which is a group of companies working on those open standards, asked his colleague, Jim Pivarsky, to create this new standard, which was based on JSON and which considered the questions, the problems that PMML users encountered. Mainly the problem was, okay, so PMML describes all kinds of models. But if you have a model that is not yet described by the PML standard, then you have to use some extensions to represent this model, because the next PML release probably won't come very soon. And so you need to use extensions. But if you use extensions, then you lose your portability. So considering this experience, Jim Pivarsky created PFA as a very different, using a different approach. it's kind of a small programming language rather than just description of the model. So instead of describing the models, it is describing the scoring procedure in a specific way that is portable and pretty flexible. Well, in this presentation, I don't have examples, but later, if you want, I can show you some examples of how it looks. Basically, it's some JSON. Yeah, and then another thing which mlib is not exactly open standard, but it is a model representation which is very efficient for at least some models, at least for SparkML and scikit-learn models. It seems to work pretty well. It is based on protobuf, which is a binary format, but apparently it works pretty well for model deployment, but it's not as widely supported as PMML is. And you can find information about mlib on combust.ml website. Finally, all those standards were very good at traditional machine learning, but they did not develop fast enough for deep learning. And as you know, in the last, well, since about 2012, right, deep learning has exploded in its popularity. And there are so many different deep learning frameworks. And it was very difficult to exchange models between the different frameworks until ONNX came about. So ONNX is Open Neural Network Exchange. It's based on protobuf binary format. It was open sourced by Microsoft and Facebook in September 2017. And since then, it has become very popular, and there are hundreds of people working on it. And it is used by many people as well. And you can find all the information on ONNX at the website onnx.ai. And I've been working with ONNX for the last year or so. Okay, so let's see how those JVM-based packages that we discussed before support those open standards. Well, I can say that SparkML is a champion. So SparkML to PML, yes, you can export those models using JPML package, which is an open source package, which is maintained by Villu Rusman in Estonia. SparkML to PFA, there is a library called ArtFark that was developed by my colleague Nick Pentrias, who actually lives in South Africa. And he is a very good guy, and he developed this library that exports most of the SparkML models to PFA. SparkML to mlib is kind of native library that does it. And then there is a good scoring engine for mlib. And SparkML to ONNX, this one may be slightly less developed, but there is some. At least some part of it in the ONNX ML tools library, which is part of the ONNX GitHub repo. Now here I wanted to show you one example of a practical application of some of the open standards. So last year in January, we had a joint poster at a conference in Switzerland with Nick Pentrias and this guy Ludovic Claude. And Ludovic works for CHUV, and CHUV is some medical organization. So that works with this Human Brain Project, and they work with this library, with a network of hospitals in Europe. And of course, in each hospital, they have certain data that they have about patients, but due to privacy considerations, they cannot exchange data between hospitals. So they build models separately in each hospital, and then they send those models around and, and they convert them to PFA and use that PFA representation of the models to validate the models and to deploy them, and maybe combine into some ensembles of models, whatever they want. So PFA works very well for that. I think they may have been able to do the same with PMML, but for some reason they chose PFA. So this is a practical application of PFA. And Ludovic actually created some open source libraries related to PFA as well. That's how I know him. Now, another open source package is RapidMiner, and RapidMiner has pretty good PML support, but there is no support for other standards, to my knowledge. And deep learning for J, there is some ONNX support in progress, but not much other than that, to my knowledge. Now, how do you deploy those standards? If you have PML model, you can, with open source. Of course, there are several commercial products, including some of the IBM products, where you can deploy PML. But in terms of open source, there is this package PML4S, where S stands for Scala. This package has Scala and Java API, and it can work in Spark. And the actual deployment is very easy. So if you have your PML file, you just give that space to this class model that you import from PML4S package, and then you just say predict, and you give it data. It allows you to give you data in several different formats. It could be a map, a dictionary, something else. And this PML4S package also has a Python wrapper as well, so it could be used from Python as well. And if you have PFA, how do you deploy PFA models? Well, there is this Hadrian package. This was developed by Jim Pivarsky and his colleagues. And then there is also this company group called Auto-Deploy AI, about which I did not find a lot of information, but apparently they have tools to deploy PML, PFA, and ONNX. Yes, and if you want to deploy ONNX, there is this ONNX runtime, which is open source library from Microsoft, which does very efficient ONNX scoring. And then again, there is Auto-Deploy AI. And also another way is there are many converters. So for example, there is ONNX to TensorFlow converter that actually an IBM team is developing. There is a converter from ONNX to MLIR, which is some kind of low-level representation, and that's done by IBM research team. So there are several ways to deploy those open standards as well.
Svetlana, can I ask a question about that?
Yes, yes, please.
If you go back a slide. So you've got that,
this one?
yeah, the ONNX to TensorFlow.
Yes.
TensorFlow seems really big, and it's difficult to really deploy it except for one application per model. I'm wondering, is ONNX any smaller, like the same model, or?
Well, actually, TensorFlow you can deploy using. There are different parts of TensorFlow. There is TensorFlow RT, there is TensorFlow Lite, there is TensorFlow JS, and those things I believe work very well for deployment. So if you convert your model from ONNX to TensorFlow, then after that you can convert to one of those things. Oh yeah, there is also ONNX.js, which may be a good way to deploy, but I think it's a little outdated. I think it was not updated recently, maybe. So if you want to contribute to open source libraries, there are several libraries in ONNX where you can contribute. But TensorFlow, definitely, it has various ways of deploying.
Okay, thanks.
Yeah. I can find more information about this if you want. Okay, so let's see. Yeah, so conclusions was that, yeah, open standards provide this flexibility and you can exchange models. And yeah, not only open source, but many commercial tools also support those standards, which makes them more attractive. And SparkML has pretty good support for all those standards, or most of them. And most other JVM-based machine learning tools maybe could benefit from adding more support for those open standards. And you can follow me on Twitter, and here is my email. Any other questions? No? Okay, well, maybe I was talking for too long, sorry about that. But yeah, in any case, do let me know if you have any questions at any time. I'm always happy to talk about PML and other standards. And I think, Luke, we have time for you now.
Okay. Mine is going to be super quick. I don't have any slides or anything. It's literally a few notes that I was cobbling together last month that I thought was kind of interesting. Let me just share my screen. So let me close this guy.
Maybe you introduce yourself.
Oh yeah, my name is Luke DiLiberto. I am a machine learning engineer at a company called PH Data, which is like a data engineering firm. Before that, I was a machine learning engineer at GoHealth. Before that, I was a data scientist at Crow, which is we did like internal projects. It wasn't external facing. So yeah, so I've walked the line between like data scientist and then I went into like machine learning engineering. And you know, one of the things that I encountered was like SageMaker. So you know, regardless of what your opinions are on like AWS and their services, SageMaker does make it easier to, like, I'm assuming people here like have, say, experience deploying a model to a Flask app, right? And what SageMaker does, if you're not familiar, is it makes it easier. You can kind of like do that without having to write much code. So it like affords your team a level of consistency that reduces tech debt and makes it easier to make like changes across your team's like set of models. It does have some limitations, but you know, you can kind of work around those. But I was building an R framework for SageMaker so that we had a client that wanted to be able to deploy arbitrary R models to SageMaker. So I was kind of like going into the details of their SageMaker containers, and I came across this idea of like deploying pipe mode algorithms to SageMaker. So let's back up. What is pipe mode for SageMaker? So what it does is it lets you, what SageMaker does is it downloads all of your data into the container for the model when you're training. So you can imagine if you have a lot of data, that's going to be, number one, super slow, and number two, it might cost money, all this stuff. And so with pipe mode, you can stream the data directly into your container to train.
Luke, I'm sorry to interrupt. Is it possible to make the font larger?
Sure, let me see. How's that?
Yeah,
Okay.
Looks better, thank you.
And so this document, I'm just going to go through like a set of curated links that would take me through like how to do the SageMaker, how to roll my own pipe mode model. And like a pipe mode model might be something like, you know, if you want to use like Vocal Wabbit or something like that, or UMAP, something like that's not already on SageMaker that you want to actually like deploy. It'll finish quicker, it'll need less disk space, and your training jobs are just going to start much faster because it doesn't have to download the data. And like, just like from personal experience, it's nice to force your algorithm to be like streaming, just because it forces you in kind of a dumb way to like think about scalability from the very get-go, which if you don't think about will most likely bite you. Here's the first link. It's like just the architecture. If you guys haven't seen this before, this is where this training data is downloading from S3, which is the object store for AWS, into the training instance. And so that's pipe mode is going to let us not have to download this entire thing. It's going to stream it into the model for us. How do I close this?
I'm sorry, question. So you're saying that it will stream. You mean it will be just a single data pass?
Yeah, I'll show you. It will stream as many bytes as you want to put into it. So like if you're going to put in a mini batch, then you have to specify, okay, how much data is going into it. Or you can also specify, some of the algorithms allow you to stream in CSV data to it too. So you just have to specify how much data you're sending in.
Yeah, but I think many algorithms require several data passes, right?
Yes. So when here, I'll show you right now. When you define, when you are reading from the queue, you're going to tell SageMaker how many data points to read in, right? How much data to actually read in from the queue, so that like when the algorithm trains on it, it'll train on, you know, however many 50 data points, 100 data points that you're streaming in. Does that answer your question?
Not exactly, because in my experience, implementing statistical and machine learning algorithms, you have to go through the same data many times for most algorithms.
Yes, and you can specify how many epochs you want to go through.
Okay.
Yeah,
okay.
The details for it, I can go through here. Well, I'll get there. It's at the bottom.
Okay.
I'll actually show you the code that goes through that AWS is. It's not my code, it's AWS's.
Okay.
These are, and like before you actually do this, you have to like get familiar with actually AWS's coding conventions or container conventions.
Okay.
And all that documentation is available here.
Okay.
This is like the file structure that gets created in your container, so that when you build your model, S3 is going to replicate that model back. SageMaker is going to replicate that model back out. These are your input data channels, so all that data that we're specifying, if you're not using streaming, all that's going to get copied here, and then your hyperparameters, all that. So you don't generally have to worry about this stuff, right? SageMaker is going to do all this for you, unless you want to roll your own algorithm or roll your own streaming algorithm. I'm just putting that in for reference. This is like my cheat sheet. In addition to like, you know, I said you can use CSV data, but generally you want to use protobuf record IO format, and it's just a binary serialization format that lets you push more data through the pipe as you go. And it's like recommended. AWS recommends that you use record IO format for training data. It allows you to, quote, take advantage of pipe mode when training the algorithms that support it. So what you just have to know about that is it's a protocol buffer format. It just serializes data, and you don't have to worry too much about like converting, you know, your JSON data to like CSV file to CSV data. And AWS has documentation on how to convert your data into record IO format. It's here too. Also, the other reason I came across all this info is because I was training for the ML exam, the AWS exam, and a lot of this stuff was very helpful in training for that. So if you're interested in passing that exam, doing this will kind of like help you figure out how SageMaker works. Like I said, like thinking about this from the start will start you thinking about scalability, and you know, if it's not scalable, it's probably not productionizable unless you have like a very limited use case. And like I said, you can use pipe mode with CSVs. There are like native SageMaker algos that, you know, will support CSVs out of the box. And then if you wanted to roll your own that supported the protocol buffer, you would have to go to those containers and read out, like, you know, how they're probably just transforming the data from protocol buffer to CSV, but you would have to do that yourself. There are some places where you don't want to use pipe mode. If you wanted to, like you were talking about, if you want to backtrack or skip around an epoch, you can't do that. So you can't seek in a queue, in the FIFO queue that's used for pipe mode, but you can run different epochs. And then you can't, you know, if you're using, obviously if it's small data, it's Iris data set, you don't worry about it if it's in memory. And it's not, if it's not easily parsable. So this means like, does it not fit into a record IO format, essentially? This is what I kind of showed you before. What's the format of the SageMaker container? You just have to like familiarize yourself with what are the conventions, where does this data go from? Also, like when you issue a command from the Python SDK, how is that getting translated into a call to the to like the Flask app, right? Like what commands are being invoked, or what endpoints are being called. This is just some background. Like if you're going to do this and roll your own, you should probably know about like named pipes. That's what's backing up this idea. This is a pretty cool article from 1997, which is nice to know that some technology lasts. I would take like a quick look at record IO, the protocol buffers, which is what's the idea behind this record IO format. These are actually pretty cool in general. They're kind of nice. You like kind of create a client, like a client plugin, so you can kind of like transfer data between like arbitrary kind of applications, right? So named pipes let you kind of pipe data from one application to another, and this record IO or these protocol buffers let you not have to worry about changing data formats, or you worry about it, but you worry about it up front between changing data formats from like, you know, Java to like whatever, like R. You can kind of like, it makes data exchange much easier. Look at these, the dev guide, and then don't worry about that. And you know, like you know, when you're looking through the documentation, the only good documentation is source code, right? So actually, some of this stuff on AWS's website is out of date, so you're just really literally going to have to go to this source code to figure out how it works. This is the actual link where you're kind of like bring your own how to roll your own pipe mode, and then in order to do that, you're going to have to actually know the format, like I said, of how to roll your own SageMaker container. It's pretty straightforward. You just follow the tutorials. The one thing that's lacking in this pipe mode tutorial is that it doesn't have an inference endpoint. So if you're going to do this, you just have to make sure that you do like an inference endpoint too. So that's all. I mean, it's just super quick. It was stuff that I thought was kind of interesting. Even if you're as a side note, even if you're not going to use SageMaker, it's kind of nice to be able to look at like, what would AWS do? So like if you have your own like Kubernetes, like on-prem thing that handles your own models, like you can, and you want to handle, so you want to deal with handle a pipe mode algo. Like it's nice to be able to look at AWS's containers, which are available on their GitHub, and see how they did it. So you can kind of like get inspiration if you're going to, you know, deploy this on your own like custom bespoke system. So yeah, that's it. This is very much a lightning talk. It's not a presentation. It's just something I thought was cool. And that's all I got.
Great, thank you so much. I think that's very helpful. Will you share this document somehow?
Sure, I can put it on my GitHub or something.
Either your GitHub, or maybe we could put it in Chicago ML Slack or something.
All right, yeah, I'll join. I'm not on that Slack channel, but yeah, I'll join it.
Yeah, I highly recommend that people join this Slack. Garrett, can you maybe put the link again in chat for the Slack?
Yep.
Yeah, so this is great. Well, if presenters would like to share the slides, maybe you can convert them into PDF format and put them also on the Chicago ML Slack somewhere. Should we create a new channel for that, or just put it? What do you think?
There's a presentations channel.
Ah, okay.
Yes. Yeah, that's fine. It's a good spot.
Okay, let's put our materials in presentations channel so people can see. And make sure that you include your contact information. So if people have questions, they can find you. Right? Okay, anybody has any more questions? Suggestions? Wait, I wanted to say something else, but now I forgot. Anybody has open positions by any chance? No? All right. Well, I think maybe we'll meet again next month, right? Got it.
Yeah, anytime.
So if anybody else wants to present something, maybe send us a message and we can meet next month. Well, anybody has anything else to say?
No, well, I do have something. Thank you for all the presentations. I thought it was wonderful. I'm looking forward to next month.
Thank you, David. I agree. Everybody.
I'll as soon as we're done here, I'll get this posted up to a YouTube link so folks who weren't able to attend can see it. Yeah, a lot of great content. Thanks, everybody.
Thank you. Thank you, everybody. Have a nice evening.
Thank you, you too.
Okay, you too.
Bye-bye.
Thank you so much. Thanks, Svetlana, Garrett,
Thank you all.
everyone else.
Bye.
Yeah.